Hey guys, Seth here with Arc & Chip Fabrication. Welcome back. If you watched the last video, we were in the middle of doing some milling and, well, something let loose that wasn't supposed to let loose. We lost the leather drive belt on the milling machine. Now this has been spliced a few times and it's pretty well dry rotted and shot. So what I'm going to do is I'm actually going to replace this belt, but not with leather. So, little story, we had an auction when I was in South Carolina I went to, and picked up a cart specifically for a drill that was on it I really wanted. And I ended up getting this whole cart of miscellaneous stuff that I had no clue what it was. And it turns out it was a belt vulcanizing kit for Siegling manufacturing belts. So I got this cart for one thing, and it came with the grinder, it came with the heaters to cook the splice, it came with the solvent for gluing the splice together, and I got, I don't know, probably a couple thousand feet of belting with it too. So didn't know what I was going to do with it. Half thought about getting rid of it. Now I'm glad I didn't, because when I got this lathe, the leather belt was shot on this one too, and that let loose, so I was able to replace it with a more modern, I believe it's a nylon, some nylon synthetic belt. And honestly, it's worked great for the lathe. I've had really good success with it. It does not slip. It's got some stretch to it, so it's pretty forgiving. But it's worked really good on the lathe. So I'm going to go ahead and try to glue one of these up for the milling machine and see how that works out. Alright, so this is the taper attachment. This top block opens up. It's got a few hand screws on here with a bar that runs across. And you open this bar up and you literally stick the belt through here, and it rests on this radius surface. You clamp it down, and then once the belt's in there, you close that. You hold this lever forward, and what it does is it moves that whole assembly into this drum sander here. There's a drum sanding wheel in here, and this is on an eccentric. So what it does, when this is forward, you pull this back, it grinds a taper onto these belts. Now this is a piece of belting that I got on the lot. It's pretty thin. It's about a little under 1/8 of an inch. I'm sure it's a metric. Not sure what. I don't have any data on what this belting is. I've looked through a few of the spools. There's no stickers or tags or anything to tell me that. But it came with a cement, K2000 cement. And like I said, I've already done it with the belt on the lathe, and it's holding up great. So I got this belt measured. The old belt was 202.5 inches. So I'm going to make the new one just a little bit smaller. I think I'm going to go 202, shave off 1/2 inch, just because these do have a fair bit of stretch, and the drive belt that's on that milling machine is much longer than the belt that was on the lathe. But at least the nice thing is I can make this belt off the machine and put it on the milling machine, whereas the lathe, I had to cook this one in place for it to work. But and that's it. It ain't pretty, but it works. Here's one end of the belt. It grinds one side off till you get a nice taper to it. And so then you glue up both these tapers, put them together, I'll show you. We got the press that heats them up. You cook them for, I don't know, I cooked them for an hour and it worked pretty well, so I'll probably keep doing that. Again, not sure exactly how long you're supposed to cook them by the manufacturer. Now, they are still in business, the Siegling Manufacturing. Now it's called something else. It's 2 words, but in any case, that's step 1. So now I gotta get this down to the other end. We'll get this one tapered out. Alright, let's try this again. I had to put some new sandpaper on the drum because the old stuff wasn't working too well. And yeah. So, anyways, got some new sandpaper on the drum. Let's give this another go. Oh yeah, that worked much better. Alright. That's one end. On the first end that I didn't cut this belt to length because this is one of those things where I haven't done many of these. This will literally be the second one that I've done. So I didn't want to goof up on it and make a mistake, so that's why I ground one end, ground the other end, and now I know how the taper's going, so we'll be able to make a belt work. Because the taper's on the top side of this one, we want the taper to be on the bottom side of this one, so we got to flip it over when we put it in here to grind it. So that's flipped over. It's flush at the bottom. Tighten the clamping bar down. Let's go ahead and get this one ground. Alrighty. Alright. There's our belt. That was a 1/2 inch shy of the mark. That'll line up pretty good. So next thing, I'm going to get the heaters out. We'll glue these together and get them cooking. Here's the base. Here's the top heating element. Just plugs into a normal 110 volt outlet. It has an automatic thermostat built into it, so it'll maintain the temperature. And basically, you build the splice underneath it, put this on it, clamp it down, plug it in, and let it cook for a certain amount of time. From what I could Google and try to find out, it seemed like an hour was sufficient for these synthetic belts. And that's all the more I did the belt on the lathe, and I tell you what, I haven't had any issues with it. It hasn't come apart, not even trying to come apart. So I'm just going to go with an hour and a little acid brush, paint that joint. Flip this end over. Go up this joint. All right. As much as I'm not a firm believer in duct tape fixes everything, I will say it has its place sometimes. Duct tape that one down. That's that. A piece for good measure. Alright. Now, move these ones over there. One piece, another one on there for good measure. Yeah, I might end up making a new clamping apparatus for this, because I definitely see where it would have its advantages. So there's that. We'll get another sheet to put on top. Splice. That looks good. Alright, that's that. Tighten these down. Clamp down good and tight. Okay. Now, got our extension cord here. Get that plugged in. There we go. The red light's on. So we'll let it do its thing. Close this glue back up. And yeah, that should be that. So we'll let that sit for about an hour. Come back out, check on it, and hopefully we'll have a nice new belt ready to go for the milling machine. Alright, so we've had this cooking for about an hour, so I'm going to unplug it. We'll open it up and see how the splice looks. Iron, it's still piping hot. Splice. Pull this tape off. Alright, and I'm pretty happy with how that turned out. Looks good. We'll let that cool. Get the excess goobers and that trimmed off here. And it was actually when I did the belt on my lathe, because I had to glue that one in place. I just got it torn apart, got the equipment put away, tensioned it, and it was good to go. I think this one's about good to go itself. So let's go try getting this put on the milling machine and see if it'll work. Alright, so we got the new belt on. Had to take in the tensioner a little bit, quite a bit, but I think it'll work out really well. It'll keep the belt snug on the bottom, so I don't need to worry about it slipping off. Because this belt is so much more narrow, it doesn't quite have the support that that wide 3-inch belt had. But it went on there nice, tensioned up good. I got it under power. And it's alive. So tracking pretty good. Staying right about the middle of the pulley. It's staying towards the front of this pulley. I don't need to worry about it slipping off the front of the drive pulley because it has a lip on the front. So with this tensioner, if you had to let it off because your belt was too tight or you couldn't get it on there, that bottom pulley's got a lip on it. So even if these pulleys aren't perfectly in line to get it to rotate, it won't suck into the chain that goes to the motor. But anyways, I think that's a wrap. Milling machine should be good to go. So I guess next we're going to keep plugging out these blocks. So thanks for watching. Hope you like what you saw. If you do, please give me a thumbs up, like. If you want to see more, go ahead and subscribe. I'm going to try to keep putting some videos out here and there, little odd jobs, and more or less working with older equipment. Stuff that's not going to be quite as nice and tight tolerance as modern machines, but still get more than their fair share of work done. So thanks for watching. Have a great night.